We'd already learned that pressure increases as we go deeper in a fluid. What we want to do now is figure out what is that relationship, how do we figure out how much pressure there is at a certain depth within a fluid. And so let's say we have a fluid here, and we have a certain depth. We designate that with the letter H. Could be a height. How high is the water level above our object? So let's say we have a fish at a certain depth. How do we calculate the pressure at this object, at this fish? And the pressure at the fish is equal to the pressure at the top, in other words, at zero depth. So P sub 0 is pressure at the top, at zero depth, measured in pascals, plus the density of the fluid. So rho is the density of the fluid that we're in, and that's measured in kilograms per cubic meter, times the gravitational field, which is still 9.81 newtons per kilogram, times that depth. So H is your depth or your height, and that's measured in meters. And so we can calculate the pressure at the depth we want by adding the pressure at the top plus the density of the fluid times the gravitational field times the depth. So let's actually go through a derivation here. Let's say we have two fish swimming in a freshwater lake, one at a depth of 14 meters and the other at a depth of 98 meters. Assuming that the atmospheric pressure at the lake surface is 101,300 pascals, what is the difference in pressure on the two fish? So we have our water here, and we have our first fish, which is at 14 meters, and we have our second fish way down here at 98 meters. And we are told here that we're in a freshwater lake, so we know the density of the water to be 1,000 kilograms per cubic meter. And we know that the pressure at the lake's surface is atmospheric pressure. It's touching the air. And so the pressure at the top, since it's touching the air, is atmospheric, 101,300 pascals. So we want to find the pressure of the two fish and then subtract them to find the difference. Let's first find the pressure of the orange fish, the one at 14 meters deep. So our pressure equation is, pressure is the pressure at the top plus gravitation, or plus the density times gravitational field times the depth. And so we have 101,300 pascals plus 1,000 kilograms per cubic meter times 9.81 newtons per kilogram times 14 meters. We get the pressure of the orange fish, we'll call this the first fish, and we get that to be 238,340 pascals. Now we'll find the pressure of the second fish, which is again the pressure at the top plus the density of the water times gravitational field times the depth, in this case 98 meters, that's our only difference. And so we get the second pressure to be 1,062,380 pascals. Now the question was asked, what is the difference between those two pressures? How much change in pressures is there? So we simply subtract the two pressures. So we have 1,062,380 pascals minus 238,340 pascals. And we get that change in pressure comes out to be 824,040 pascals.